Hi, this is the part 3 of my lecture series, Why Do Structure Fails? And here in part 3, I'm going to talk about the ethics, ego, and professionalism. So, the first two lectures we talked about physics, resonance, and the mechanics of failure. But structures are designed, built, and managed by people, us. And people are like fallible. Today we conclude our series by looking at the most unpredictable variable in any equation, the human element. So we will discuss how professional pride, the pressure to save money, and the normalization of small errors can lead to catastrophic disasters. This isn't just a lecture on engineering, it's a lecture on the ethics we have to follow as an engineer. So coming to the next slide. Um, while a structural fail means while gravity is constant, human judgment is not. Today we look like how pride or greed or silence can just be as destructive as a hurricane. So normalization of deviance. A term, uh, a term coined after the Challenger shuttle disaster. So, normalization of deviance, which is one of the most dangerous psychological states in engineering. It occurs when people became so accustomed or to a flow or a near miss that they stop seeing it as a danger. If a building shows a small crack and it doesn't fall down today or tomorrow or next week, the human brain begins to accept that crack is normal. We stop investigating. We assume the factor of safety will protect us forever. But as we will see, nature eventually collects on every debt that an engineer ignores. So we will shall go to a very interesting one of the case study, City Cop Center. Mm, it happened in 1977. The City Cop Center was completed in New York City. It was a marble design, a 59-story tower sitting on four massive stilts to accommodate a church at its base. It was bold, iconic, and, as it turns out, fundamentally flawed. The lead engineer, I think whose name is Mr. William, he was a legend. But after a year, the building opened. An UG undergraduate student called his office to ask about the quartering winds hitting the corners of the building. So Mr. William realized that his team had made a catastrophic assumption. They only calculated for wind hitting the flat sides of the building. Nothing happened actually in the building, but quite happened after noticing the after construction after construction noticing these things, we couldn't able to rectify that kind of things. A UG student actually revealed it actually. So the another one of the case study is like mm, one more thing I am adding to that case study. Mr. Williams specified that in a quartering wind, that wind affecting the stress on this bolt increased by 40%. His calculation showed that once in 16 years, Tom would shear those bolts and the building would topple over the middle of the Manhattan, New York. This wasn't just a mistake, it was a ticking time bomb. The human element here wasn't just the error, it was just happened next. Uh, Mr. William then faced a career ending choice: stay silent and hope for the best, or admit the error and face total ruin. He chose the latter, that he informed the city, and a secret emergency plan was launched while the city slept, and with a hurricane actually forming in the Atlantic. Welders worked throughout the night to reinforce every single joint in the building. This story is unique because I'm talking about the last slide. The failure was prevented by professional bravery. It teaches us that your integrity as an engineer must be stronger than your ego. If you if you think it's wrong, admit it because it's a building. So we can another important case study we can go come across like Samsung department store. Its location is Seoul, South Korea. This is the story of greed actually. The building was originally designed as an office, but the owner changed it to a department store on the mid of the construction. So when the original contractors refused to make dangerous changes, the owner fired them and hired his own company. So to add escalator, they cut away supporting columns. To save money, they used thinner concrete to maximize floor space. They moved heavy air conditioning units to the roof, units that weighed 4 times more than the roof was designed to hold. So, how about it? Great, no? That building was essentially uh, lost. The most critical failure was punching shear. Of course, they can't withstand these kinds of things, no, because the columns were too thin and the floor were too heavy. The columns were literally ready to punch through the floor slabs like a pencil through a piece of paper. The owner knew there was a problem. They saw the cracks growing, but instead of fixing the structure, they simply moved the expensive merchandise to the basement and kept the store open. They prioritized the day's revenue over the lives of 500 or thousands of people. On the day of collapse, the cracks in the ceiling were so wide that management finally closed the top floor, but they still refused to evacuate the building. So almost like I think it about like 5:53. Yeah, at 5:52 p.m. the roof gave way. Yeah, it collapsed. The entire structure is it's like a pancake in just 20 seconds. The human failure, we can able to sell it as a human failure, not structural failure. It's a human failure was the silence of the engineer who were overruled and greed of the owner who ignored them. And about 502 people died. As an engineer, you must be the voice for the building because the building cannot speak for itself, but you are the owner. You can speak. Uh, this is the I'm talking about this column. This is how it was. The cost of silence, 502 death that I talked about. The engineering code of ethics is very important. Very, very, very important. This is why every major engineering society has a code of ethics. The very first canon is engineers shall hold paramount the safety, health, and welfare of the public. We serve for the public. This means your first loyalty is not to your boss, but not to your client too, but or not your for your paycheck. It is to the person walking under the bridge or sleeping in that building safely. You have a whistleblower responsibility. If you see something unsafe, you are ethically responsible and often legally bound to report it. So I for this I could able to tell that we have reached the end of this series of this lecture series. We have seen resonance of the bridge like and bolt and like ethics. Always remember your drawings are more than lines. They are contract with society. Learn from these failures. Respect the math. We are all everything is depends on math for our in civil engineering. And above all, respect your ethical duty. The price of an engineering error is too high to be paid in human lives. So thank you so much for paying attention. We'll see you on the next lecture series after a while. Thank you.